All right, section 4.5. We're still dealing with triangles. Let's label this. Let's call this ABC. Let's call this DEF. All right. Now we've learned two ways. Just review real quick. Yesterday we learned two ways to prove triangles congruent. What was the first way? We did it a lot when we went over the homework today. Side, side, side. Okay. So side, side, side is one. What was the second way? Side, angle, side. Now what had to be true about that angle compared to the other two sides? Now think about what I'm saying. This angle between the two sides. I'll give you, for instance, watch. What if I was given this side equal to this side and this side equal to this side? This is just review from yesterday. Where does that angle have to be? Does it have to be here, here, or here? Give me a letter. At B. That's right. Between the two sides. Now we gave that a word. Does anybody remember the word? Instead of saying it's in between, that's kind of more of a normal everyday type of word. What's more of a geometry word? We talked about it yesterday. What is it? It starts with an I, not in between, but no, included. Thank you. This is the included angle. When I say the included angle, it means the angle that's between these two sides. You got it? What about angle A? Is angle A the included angle of these two sides? No. It's the one that's in between it. Look what it does. It joins those two sides together, doesn't it? See that little arc? We call that the included angle. So if I have this information right here, if I have a side, angle, side, and that angle is in between, or it's the included angle, then the reason these triangles are congruent is because of side, angle, side. You got it? All right. Let's get rid of all that. And so those are our two ways so far. Now, today, I'm just going to show you a couple other ways you can do this. Here's another way. I'm just not going to go through really any explanation. It's also a postulate. Remember we talked about a postulate yesterday? We said a postulate does not have to be proven. So we just accept it, right? Somebody tells us it, and we just accept it. That's a postulate. So here's another one. Watch. What if I was given that this angle is equal to this one, and this angle right here was equal to this angle right here? All right? But I also told you that this side, BC, was equal to this side, EF. Now that's different. That's not side, 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 is it? Okay? It's not side, angle, side. I only know one side, don't I? Okay? This is not angle, angle, side. Look where the side is. It's between the two angles. So what do we call that? We call that the what side? Included side. Right. We call this the included side. So the reason that these two triangles are congruent is because of what? Angle, side, and an angle. And that's what I'm going to write right there. Angle, side, angle. Now remember, we don't say ASA, do we? We say angle, side, angle. But we write it capital A, capital S, capital A. Everybody got that?
How would that make them know that they're congruent?
Well, you could try it. Now it's a postulate. There's no way to really prove it, but you could try it. I could give you you take two lengths that are exactly the same, right? And I say, okay, I've got these other sides, but I got to make that other side a certain angle, and I got to make this another angle. Now these angles don't have to be the same, all right? But if I took like a stick, a piece of toothpick or something like that, skinny little line. If I made this line the same as this line right here, and I said, okay, my second side has to be a certain angle to this line, and my third side has to be a certain angle to this side, everybody in here would draw the exact, or would construct this exact same triangles with each other. There's no way, because watch, if I took this and I said, well, I'm going to make this different. What if I slanted it out this way? Then what's going to happen to that third side? That's going to be longer, isn't it? Or if I took it and I slanted it this way, that third side is going to be shorter, right? But if this angle is the same as this, there's no other way to draw this side, and there's no other way to draw this side but to make them the same, okay? So anyway, that's a postulate. That's angle, side, angle. So now we know three ways, don't we, to prove triangles congruent to each other. No, there's a bunch of ways. Here's another way. Watch this. What if we've talked about this before. I don't know, the other class acted like we'd never mentioned this before, but I'm pretty sure we did. A couple of them said we did, so I think we did. If I have two angles of one triangle equaling two angles of another triangle, do you remember what's true about the third angles? They got to be equal as well. And there was a reason for that. Do you remember the reason? There was a name of a theorem. I mean, you're right. I'm not saying you're wrong on that, but there was a name of a theorem. No, it's the third. Do you remember this? No, the third angle theorem. I think we did. Yeah, we did. All right. See, you sound like my other class now. Some people say we did, some people say we didn't. But we did. I'm telling you. Look it up. Okay, it's on YouTube. It's all recorded for you. All right, so you can find it. It's called the third angle theorem. So this angle is equal to this angle right here. Now watch. What if let's take this one away, and let's take this one away. Are you watching? Now, is the reason these two triangles are congruent because of angle side angle now? No, because I don't have, this is not the included side, is it? All right. That's right. This is angle, angle, and one side. Now, the side is not included, is it? You're like, well, how do you know that it's angle, angle, side? Well, because if I know these two angles are equal, what must be true about this one and this one? They got to be equal. So now, why are the triangles congruent? Angle, side, angle. You see it? But I don't have to go that route. I don't have to know all that information. All I need to know is that I have two angles and a non-included side. If I've got that information, then I can say the triangles are congruent. Isaiah, you getting all this? Do you concentrate better with your eyes closed? All right, so watch. Angle, angle, side. Remember, this side is not the included. Now, it's kind of like this, isn't it? All right, because I got two angles and a side. All right, but the reason, again, if I was given this original information right here, why would the triangles be congruent? Angle, side, angle. Okay, but you could also say what? Angle, angle, side. Or you can use this one, couldn't you? Angle, angle, side. You get it? All right, so now we have how many ways so far to prove triangles congruent? We have 4 ways. Now, there are other ways. I don't think we do any more in this chapter, but we may in another chapter. There are other ways to prove triangles congruent. For right now, though, we're just going to stick with these 4. You okay with that? Let's do a quick example of the kind of stuff you're going to see on the... Remember, we're going to do proofs on the worksheets, but you don't have to do the whole proof. All you got to do is mark the picture and then tell why the triangles are congruent. Okay, that's all you got to do. So let me draw one. I'm going to take one from the book, I think, for an example, and then we'll do it together. All right, here's our situation. I've got this picture right here, and I've labeled it, got the given, and this is what we want to prove. We want to show why. We want to give a reason why that these two triangles are congruent. So part of what you're going to do, this is the kind of stuff you're going to see on the worksheet. Part of what you want to do is to mark the picture first. All right, so let's mark the picture. Angle K equals angle M. So we come over here. This is what I want to see on your picture. All right, so K and M are equal, so we put one arc for K and one arc for M. Everybody good so far? It's pretty easy, isn't it? Everybody can do that. It also says that JK equals JM. Well, find JK. JK is this side. JM is this side. They're equal to each other, so what do we put on it? Tick mark. Right. Little tick mark. All right. Now, here's the part that's you got to think a little bit. It says JL bisects. Well, here's JL. What does it bisect? KLM. KLM. This big angle right here, that JL bisects it. So what does that mean if it bisects it? That's right. These two little angles are equal to each other. All right, so this angle right here equals this angle right here. Do you see how we did that? Okay, we marked it. We marked them all out. What did KL and LM be equal to each other? Well, we don't know yet. They didn't tell us, right? There's really no way to say that KL and LM are equal to each other. I mean, they look like they are, but just because they look like they are, does it mean they are? No. Okay, so what are we trying to do, though? We're trying to prove that those two are congruent to each other. Yeah, but JL could... Look, watch this. If I had an angle like this, right? Listen to me. And if I said that this bisects that right there, okay, does that mean that this length is equal to this length just because it bisects it? No, it doesn't. It doesn't split a line segment into 2 equal parts. It splits the angle into 2 equal parts. You follow me? So this angle and this angle could equal each other, but this length could be different than this length right here. Follow me? Okay. So we're practically done, aren't we? Why are the triangles congruent? Do I have enough information right now?
Yes.
I absolutely do. What? Angle, angle, side. That's right. Look, I got 2 angles and a what? Yeah, a non-included side, right? I've got 2 angles and a non-included side, so my reason is angle, angle, side. So 2 parts to this answer. One is this. I mean, that's the real important part right there. Okay, but the other important part is to show me on the triangle what stuff are equal to each other. This was given. That was easy, wasn't it? K and M, anybody could do that. JK and KM, that was easy. Anybody could do that. The parts that you had to think just a little bit was this, when it said that JK bisected angle KLM. You had to use some thought right there, didn't you? So you had to think, okay, what if I'm bisecting an angle? What am I doing when I'm bisecting an angle? I'm splitting it into 2 equal parts. We don't say in half, okay? We say we split it into 2 equal parts. So that means this angle equals this angle right here. Does it make sense? Okay. It kind of is, but we're not saying anything about something is half of something else, are we? I didn't say that this is half of the whole thing. I want to say that this angle equals this angle. So when I define it, bisecting, I say it doesn't split it in half. I say it splits it into 2 equal parts. All right? That way, I know that this angle equals this angle. If I said it just splits it in half, that doesn't really tell you straight up that these two are equal to each other. All right? It's a subtle difference. I understand. But it is a difference, and so we don't say it splits it in half. We say it splits it into 2 equal parts. Make sense? All right. And they're congruent because of angle, side. As simple as that. That's all the kind of stuff you have to do on the worksheet tonight. It should be pretty quick. Should be pretty easy. Not any real. There's no math involved as far as adding and subtracting and all that kind of stuff. Just looking, marking the picture, looking at it, and choosing from those 4 things. Remember earlier we had those 4 things listed? So you have an option of choosing from any of those 4. My guess is they'll probably use the 2 on this lesson. What are the 2 that we learned on this lesson? Angle, side was one. What was the other one? No, we don't say angle, side, angle. Come on. You got to pay attention when I'm telling you those things, okay? We say angle, side, and angle, side, angle. We don't say ASA or AAS. Make sense? We write it like this, but we say it angle, side. We good? All right, that's it. I'll give you a worksheet, and I'll let you start working on it.